All right, let's hold on this slide, and now let's get into the theory. When we shut the slide projector off for a moment, we'll come back to this one. Just shut the light off, we'll leave the fan on. If you don't leave the fan on, it'll burn the bulb out. Put some lights on. Now, what were we attempting to do on the Eldridge? One of the first things we learned when we went to school in 1940 with von Neumann was that we're not living in a three-dimensional universe, we're living in a five-dimensional universe. The three physical dimensions that we know, plus the fourth dimension, which of course has been fairly well defined by everybody from P.D. Ouspensky in 1931 and Tertium Organum to Einstein to others, as being time. But it's not as simple as that. I was about to say we have no chalk, but we do. Let's draw a little diagram. I would like to have these in my slides, but I haven't been able to get them made up in slides yet. Let's say that this represents the three dimensions of our reality as we know them. We'll just call them D1, D2, D3, all at right angles to each other. Everything in this room, etc., everything we know of solid three-dimensional structure. But there's an interesting point about this. These things have endurance in time. If there was no time flow, nothing would exist. They are dependent upon a higher dimensionality to exist, and that higher dimensionality is time. So we'll draw it as a dotted line with an arrow on it, indicating there is a flow, and we can call it, for convenience, T1. It is, in a certain sense, at right angles to the other three, but that is not a true relationship. It is a flow of time, and I'll get back to that in drawing up our slide to explain it further. But T1, or the fourth dimension, is not the only dimension that's involved. There's a secondary dimension called T2, or a spinner. And this thing is really a vector which rotates at right angles on T1. In other words, if I were to use this pointer to represent T1, or the fourth dimension, you have T2, or spinner, as a vector at right angles rotating around the end. But it's doing more than that. It is T2 that really is the control function, because this thing is traveling as a helix, if you want to draw it that way mathematically. And as it rotates in this manner, it is doing a corkscrew number through the universe, and that corkscrew number, the forward motion, the average time of this other vector, which I drew here, is time as we measure it. We do not measure the spinner. We only measure T1. And that T1, under all normal circumstances, is a constant that can be altered. And that's what we were working on. What were we trying to do with the Philadelphia experiment? We were trying to change the position in the time stream of the ship sufficiently with electromagnetic means that the energy which would come from a radar signal or from light would pass straight through, so far as anybody could tell or see. There would be no reflection. And if there's no reflection of any energy, light energy, radar energy, or whatever, you have no image. Everything you see or I see or a radar display screen sees is dependent upon reflected energy. If there's no reflection, you don't see anything, regardless of whether it's there or not. And that was the basis for producing the invisibility field. Now I'll go back briefly to the slide. If you want to turn the light back on and the light's out, we'll cover the slide, then we'll go on from there. In a book entitled How You May Explore Higher Dimensions of Time and Space by P.D. Palucki is the man, published 1989. He has a number of different drawings, but this one, the so-called Torus of Time, is perhaps the best and the most explanatory. How You May Explore Higher Dimensions of Space and Time by T.B. Palucki. I have it there. In fact, it's sitting under the slide tray, I think, or under the slide projector. Now, as he shows it here, and it's mathematically quite correct, you have a torus formed by time, because time is not open-ended. It is a closed loop, so far as we can tell. And this is what Einstein said, among other things. He said there is no such thing as a straight line in our universe. If you think you have a straight line and you could send a straight line out, let's say from your chest, and you went long enough and far enough, you'd wind up hitting yourself in the back. Of course, this is speaking theoretically, and also it is correct in the sense that it is a curved, closed universe. And this also applies to time. But this corkscrew spinner generates the timeline, which we reference, but it also does something else. It generates the normal reality, which we know as we exist in. But there are alternate realities. If you go 90 degrees around this torus, you will have another reality, an alternate one, very similar to ours. Many things, most things will be the same. There might be a few people missing. There might be a few additional people. A building or two might be different. But it'll appear to be exactly the same as ours because it's locked in the same time stream, but it's phase shifted by 90 degrees. Now, if you take an object, such as a warship, if you were to take it 90 degrees, it would be in another universe, so to speak, another reality. If you take it partway around, like about 60 degrees, it becomes invisible, but it is still physically there. You can go up and hit it. So that was what basically we were doing at that time. Now, of course, invisibility has seen a few improvements and a few changes. But that was the basic business, and you can have a number of alternate realities. You can also have split-offs from the main line to still other realities, and you can even go into other universes. This gets into deep theory I don't want to get into. For that matter, I don't even know most of it. It's very involved and very abstruse. But I thought you'd like to see this because this represents quite well what Einstein said in his unified field theory. It's a closed universe and a closed circuit. Preston on Friday gave more information in terms of the time sea and how the time function actually works. Yes. So let's have the lights back on and the slide projector off, and then we'll go on from there. So we still have quite a bit to cover. Now let's give a little plan drawing of the Eldridge. I'm not the world's greatest artist, like Preston. I guess I know. Neither of us are. Let's draw this sort of like this. That will represent the bow, and this will represent the stern of the Eldridge. Here, someplace in the middle, we had this antenna, we had this square room. We'll leave a lot off. We have gun turrets and so forth. We have this big antenna right here in the middle. But we have 4 coils designed by Tesla and used also by von Neumann with very little change other than he put a damping coil on the top, because when you go from a CW type analog signal to a pulse signal, these coils would ring like a banshee. 2 in front, 2 in back. These are gun turrets, so I'll just erase them. They may be confusing to you. The antenna in the center was a quadriphase antenna, which meant it had 4 phased sections to the array, each independently fed by a radio transmitter. Each transmitter was modulated by its own chain of electronics, which went back to the basic pulse generator, the zero-time reference generator, and so forth. That RF system was locked to, in terms of phase and frequency modulation generation to the pulse generator, to the magnetic system, but was independent otherwise. The magnetic system consisted of 2 huge generators, 275 kVA generators, electronically locked to each other. For reasons which I don't recall now, each had 5 field windings. There were 10 total. Each field winding was driven by a bank of 300 6L6 tubes, so there were 3,000 total. There were buffer drivers for those and so forth. They had to be able to modulate, turn on and turn off the current in the 5 windings, and they did it in a manner such that by pulsing it, they could still create a rotating magnetic field. you would phase these things. The four would be out of phase with each other, the same as here. In other words, you had a relationship basically of 90 degrees between each one for the RF and between the magnetic. They overlapped, but they did it even in spite of the fact they were pulsed.
So vertically oriented, so north, south, poles.
Correct, and that's a good point. They were conical, just about to describe that. Each coil stood approximately this high. They were narrow at the top, approximately like so. They tapered in a conical form down to the base. And tapering down to the base conically like that, they broadened out extensively, probably to about 3 feet. They had 2 cable feeds. There was not a Tesla coil in the sense of having a drive at one end only. They had actual solid cable feeds from the generators, and each coil was fed in its own separate amplifier chain, actually from the generator, because they controlled the output of each coil from 2 separate sets of slip rings from the alternators, and the entire field windings controlled the phasing of the entire system because of the drive from the electronics. It was very complex, but they did get what they wanted in terms of the magnetics, so that they phased incorrectly, and you wound up generating a magnetic field around this ship, which became, in essence, a toroid, an open toroid. Now we'll do another drawing for you. The RF fields were generated here within the magnetic field, and the two interacted. One was twice the frequency of the other. They were both tied to the famous pi over 2 series, which is very basic to such phenomena on Earth. And they were keyed to each other, and they were keyed to other mathematics, which will give you a window. Now, how do we get it? Perhaps many of you don't know, maybe most of you don't know, there's a very strange relationship existing, as was pointed out in the unified field theory, between the E field or electrostatic field, a G field or the gravitic or tachyon field, whatever you want to call it, and the H field or magnetic field. I drew them this way because you can draw them in a different form. This, if you separate out and draw it in a slightly larger scale, with the arrows pointing in, would be again your E, G, and H. The forces will be forcing towards the center. 3 interact, and of course they interact with time. And what happens is, if you manipulate E and H correctly, you also manipulate G, and if you manipulate the 3 of them, you then create a time effect. You change the local time. Now, by changing the local time, what do? You're changing the T2 spinner. So within the confines of the field, not outside of it, but within the confines of that field, you are actually changing the time flow rate slightly. That was the intent. And by changing it slightly, the ship, in terms of the torus of time, goes from its point, normal point here, we'll call it normal, to someplace up here, if you're looking at the edgewise on to the torus, to someplace up here for the ship, somewhere is around 60 degrees. And then what you had to do was maintain the fields in another manner so they would lock at that point and not slip out of our universe, and maintain the invisibility. I'm sorry? Well, if you go too far around, the ship's out of our reality in another. How do they lock it there? By changing again the rate in which the T2 spinner rate internal to the field is reduced down to what it had been in the first place, i.e. you lock at that point. You're not continually increasing the frequency. You don't maintain it at an increased frequency. You're just deriving a phase shift. When you get to the point you want, you restore the normal spinner rate in that local field. Right. That's all done through basically the generators, the main field coils of the generators. It's a very complex system. Of course, it took an enormous amount of power, and they generated very powerful fields, and the personnel, of course, were very badly hit by it. Those down below deck were not. They were shielded by the steel. with the exception of 2 men who developed a strange intermittent, one not so intermittent problem of invisibility. But those on deck went insane or disappeared totally. And I got a little more data on that too. Okay, that was basically what they were doing. What did the shape of the field look like? This was the big problem. When the initial research was started, theoretical paperwork, they had a choice. They could either develop an open-ended type of toroidal field, which took 4 simultaneous nonlinear equations, and that structure, looking at it on end, let's say from above, would show a field somewhat like this, much like a donut. And you would have an area in here where the ship was. And of course, if you look at it sideways, you would see first the water. You would see a coil, not a coil structure, but a field structure which would look somewhat like a donut. And you would have radiating out from here, of course, other aspects of the field, because the field was fairly well defined in here. And like any toroidal field, there's some leakage, particularly the way they ran this one. And you would have some part of the field structure above water and some part of the field structure below water. But here's the key point. The magnetic field coils were arranged in such manner, again, I'll draw them like this. You had a cable connection here and a cable connection here. These were on the deck, so they were pointing up. You would have all one field up one end and the other field down the other end. They would maintain the fields, and this is what you could do with pulsing it, maintain the field the way you wanted. And you wound up with a magnetic field in here, the H field, which was all one polarity above water and the other polarity was below water. That's how they just got a monopolar magnetic field around the ship above water. Below water it was damped out, so it didn't really count that much, except right around the ship, wherein, of course, the water also became invisible. The water didn't go away. It was there. They formed an actual, even though it's a dipolar field, a monopolar field in terms of above water in the ship. And that was part of Tesla's earlier research. There are papers on this, I understand, available now, but I've not had time to go dig them out. So they had the choice between the open-ended field, the toroid, or if they wanted to go to it, and they chose not to because it was much more complex, would have been an oblate spheroid type field which was closed. It didn't have a hole in the center. It was completely closed. The ship would have been enclosed in that field, and there would have been no possibility of something coming in from the outside and interacting with it. And of course, with this type of an open field, something could interact, and it did. There you had an open-ended toroidal field. The ship was in the middle. The critical date was 12 August 1983, as we found out much later, because on 12 August 1943, 12 August is the critical date, 43, 63, 83, we found this out years later, the Earth has its own biorhythms, like the human body, but there's 4 of them, and they all peak out every 20 years with a nice, sharp, synchronizing peak, 1 day wide, roughly. And that day is the 12th of August. You have to also take into account the slippage of the calendar due to the fact it's a Gregorian calendar, which will say that by the end of the century they have to add another day, so it's already slipped most of a day. So 12 August plus or minus half a day, possibly 1 day. But with that field structure, it was open. It was open to interference. It was open to coupling. So what happened? We'll do a little graph type thing. Here is the Eldridge in graphical form. 1943, 12 August. We'll draw this timeline as a dotted line. Up here we have 1983. We'll show a radar tower with a nice big radar antenna on the top. This is 1983. And you also have a date in the middle, 1963, 12 August. Here we have the fields around this ship, an open-ended toroid. Here we have this generator out here, which was much more powerful, actually, than the one down there, generating its own fields, but they were not generated by the radar antenna at that time. They were generated by a set of coils underground, a delta T function coil. On that date, the 12th of August, because on 22 July, this ship was tested and there was no lockup with anything. And we don't know now, unless Preston does from his log books, whether or not the transmitter was on that date, but even if it was on, that is Montauk transmitter, was on the 22nd, there would not have been a lockup. The two turn on that date. You got a coupling. What happens? Strangely enough, this little ship, not very little either, at 1,540 tons, takes off into hyperspace. An artificial structure in many respects, mathematically quite well defined, but in terms of the reality of the universe, it was out of our universe. The Eldridge was literally sucked into hyperspace because of the interaction of the two fields. That thing was very well anchored with a few million tons of earth, soil, concrete, and rock. And this thing was only 1,540 tons, so off it went. It wound up here. It was protected by its own fields from disintegrating, and as long as those fields remained intact, that ship remained intact and the personnel on board remained intact. Now, we couldn't control it. The thing went out of hand. We left the control room. We went outside. We jumped overboard. The ship was someplace up here in hyperspace, undefined time. You can't define time with this hyperspace function. So we jumped overboard, the two of us, and somehow we wound up back here at 83. There were two other people who jumped overboard, and they disintegrated. It was more than luck. It was, one could say, divinely controlled, one could say fate, or one could also add the factor that Duncan and I were already there, and the fact that I, as Al Bielik, was working on the Montauk project from sometime in 53 off and on until 83, and Duncan was there as Duncan number 2 on the project. He was physically there at the site on 12 August 83. I was not physically there on the site on 12 August 83. They told me to take a hike for a couple of days before that date. And Duncan was held elsewhere. But we successfully arrived for whatever reason. Then we were returning to the Eldridge back here. We went on board the ship, took access, smashed the equipment. The Eldridge winds up back here in 43 in the harbor about 4 hours later.
How did you go back? What did they do?
They sent us back by means of the time tunnels and the time tunnel operation at Montauk because they had total control over space and time. Speaking in terms of mathematics,
You stepped into something? Or?
we stepped into a hole in the wall, illuminated, which is about 8 feet in diameter, in which we were propelled down that tunnel, if you will, and wound up in the decks of the Eldridge. We didn't fly, obviously, and that ship was in hyperspace, and somehow they knew how to connect with it. Don't ask me how, I have no idea. Now, and Van Neumann might be able to tell, but he's not talking very much these days. The first one was quite terrifying. The second one, we knew what was coming, so it didn't bother us. The only thing was, in going back again, we were falling through what appeared to be a tunnel, or seemed like a tunnel, felt very strange. Very much like if you were to jump off the top floor of an elevator shaft when there's no elevator. And you go down. Of course, you don't hit the floor the way we did it, but that falling sensation, or if you jump out of an airplane with a parachute, that falling sensation you have until the parachute opens or something intercepts your fall. It's the weightlessness. It's about the same. That's a good question. There was air on board the ship. What happened when we left, we don't know. It wasn't that long. You can survive without oxygen for over 2 minutes. It took less. I'd say 1 to 2 minutes. If it was 1 minute, there would be no problem, even for somebody who was not used to holding their breath. I can't explain that physiological aspect directly, because I don't know exactly what happened that way. But 2003, you will have another potential lockup point. Well, I don't think the Eldridge is around with the equipment to do it, but this is still around, and it's operational again. They put it back online in August of 92. January 17th, 93, they had an explosion that put it offline, and then on June 17th, it blew up again. It's currently offline, but we know they're going to put it back online. They're working desperately to get it back online because on the 12th of August of 93, you have an in-between 10-year window point. Now, let me show you just a wee bit more, and then we're going to get into the time business a little more. Okay, let's draw this as a 20-year period, 43, 63. You have a semi-node point at 53, which is 10 years in between. Or if you call this 83, or rather we'll call that 2003, and call this 83. You have an in-between 10-year point, which in this case would be 93, that's this year, would be on the 12th of August. You have a 5-year semi-node point in which not much occurs, but the in-between one is active, and you can interact. We suspect, we think, we don't know, but we suspect that they want to extend that time tunnel from the year 1983 to 2003 because there is a solid wall in the year 2013 which prevents them from looking beyond it with a time machine, prevents them from doing much of anything. It's to keep this era from interfering with the future era beyond the wall of 2013. I could talk a lot more about that, but it would take much time and revealing certain confidences. But in any case, we know they probably want to extend the wall because they have complained, not to me, but to Preston, they can't view beyond the year roughly 2013 with a time machine. They don't know what's going to happen beyond that. And these world powers, the New World Order people, they're worried. Are we going to be able to extend our power? Are we going to keep operating and controlling everything beyond 2013? They're literally worried. All I can say is tough. Okay, that is really what's going on now with the 93 thing. You have this 10-year in between node point, and that occurs every 10-year point between any of the other dates. Now, let's get into something more on this time business. The manipulation of time and that sort of thing. And at this point, very quickly, I'm going to get Preston in on it. There was a breakthrough, many breakthroughs. One other item I should tell you is when they resurrected the project for the Philadelphia experiment in 1947, And von Neumann was asked to reopen it to see if he could find out what really went wrong, what could be salvaged, if anything. So he reopened it, became involved, as he was then, in many projects, but basically he found that there was a problem that could be surmounted. The basic problem was the human element, not the hardware, in terms of the ship. How do you lock the time references of each individual down, which was established at the time of conception for each individual is born into this time frame, or any time frame, when the body is actually created as a functioning fetus? It has a time lock, and the soul that's going to go into that body has a lock on that point in time so that it'll be referencing a specific point in history and not floating all over the place. And it goes through the point of process of being born. You live out your life. You know all your friends from every day. You don't slip out of the time stream and go somewhere else. But if you lose those time locks for any reason, and that is what happened to a lot of them on the Eldridge, because of the excessively powerful electromagnetic fields that wrecked their time locks, they started to float in space-time, literally, physically, as well as mentally. But they would float in that time reference, and while they were contained as long as the fields were intact, when the equipment was destroyed and the Eldridge came back to 43, the fields were collapsing, the control over those individuals was lost, they drifted, some of them wound up in the bulkhead, some disappeared, and others were pulled for another project. We have some follow-on projects. Of course, von Neumann solved the problem. In 1953, they had a totally successful test. It was then reclassified again and called Project Phoenix. Project Phoenix is a coverall for an awful lot of projects. VIR, virtual interpretive reality, for other research projects on mind control, for a number of others. We don't even know all of the projects they did at Montauk. Weather control was part of it, under Phoenix. That started at Brookhaven. Many, many projects. But when they finally solved this, of course, it went through many generations. They finally got the equipment small enough to put on aircraft. Today, it's on all the Navy fighters, all the Israeli fighters, the B-1 bomber, the B-2 bomber, the SR-71, all the large supercarriers. We don't know what else they can put it on, except we know it's down now to a nice little small package that you can put on your belt, flip a switch, and you're invisible. And the Secret Service uses it. And I have photos to prove it. I wouldn't be surprised what was in here in the last 2 days. But this is part of the ongoing research on invisibility, time shifting, time manipulation, time machines. But certain other things occurred in the 50s and the 60s, development of transistors, solid-state devices. And one of the very interesting little devices that was developed was a special germanium transistor known as the SBT, surface barrier transistor. This one was developed along several parallel pathways. There are at least 5 papers in the journals of the IEEE describing the Philco and Sprague process for producing these things, roughly from about late 1950, I think 58, 59 on. There's a whole series of these papers showing the processing techniques. These were germanium devices before they came into production on silicon. Silicon, a whole new ball game, really. But they had very strange characteristics. And we have found, by accident, by design, whatever, that transistor working in conjunction with another device and a coil can very simply produce a time-modulating field. Now I'm going to draw you a block diagram and then a very rough, crude diagram of the electronics, because it is a very simple device and it's very portable. We'll start with what is basically an oscillator. We then have the transistor. And this one goes to, I think the way it's done right now is minus 9 volts. This comes out to a coil, which then goes to ground. And of course you have an RC out here to control the frequency. It is one of these special surface barrier transistors specially developed by the government on a special program, which was literally 100% of the product went to the government. And they shut the lines down in 1971 and were told the manufacturer to scrap over 500,000 of these things who didn't scrap them. They got buried. Yeah, this coil is a special 4 pi coil, which we can explain. But what happens when you turn this thing on and when you set a frequency, which is really the oscillating frequency of this 555 square wave output? Without just simplifying this, you switch this device on and off. And because of the way this device works, in conjunction with driving some current through this coil, out of the end of this coil, you produce a delta T field. It is actually time modulating field. Now, Preston, do you want to get into the theory of this thing? Then we will demonstrate it. And I said, demonstrate it. That is a little hard to explain. I can't answer that one, really. It remained in hyperspace, and as I remember, some of the other data which has come through since indicates there was more than Eldridge in hyperspace. There was other hardware seen floating around out there, like some aircraft, a submarine or two, and so forth, which, because of the fact, I did forget to mention, the Germans were working on the same project themselves in World War II. They lost a number of submarines totally to this project, their own version. And we also had three, not one destroyer. We had DE-013, DE-078, and DE-173, which was the Eldridge. I don't know much about the other two, except they were outfitted in the Philadelphia Navy Yard. I know two people who have verified this. And one of them sank in the Azores in its test, and what happened to the third one, I don't know. But why none of them wound up at Montauk? It's a good point. I don't know. Preston, you want to take over?
Okay, before I had a piece of chalk. Before we go into the actual workings of the transistor, let's first go deeper and heavier into the delta T function. What is delta T? Delta, of course, is change. T, of course, is time. Change is modulation. Now, how do we get delta T? This can be yielded from essentially a transform, which is a function of frequency going to a function of time. How do we get this? I have to erase the beginning of the antenna here. Let's consider what really this is all about. If we have, let's call this our delta function here. This is yielded from essentially a summation, n equals 0, n equals infinity. This is essentially functions of frequency coupled with time sub 0 crossed by time sub infinity. This, of course, will give you almost an infinite series. It will just keep going on and on and on and on. This series turns out to be holographic. So we could essentially limit this by a bandwidth. What we're doing here is we're taking a frequency transform, crossing it, processing it by a cross of T sub 0, cross of T sub infinity. What is T sub 0? This, of course, is the center of the torus. T sub infinity is the edge of torus. If you remember from my lecture on Friday night, I drew the time torus, the whole time enchilada. I really don't want to go through this because this will take a lot of time to explain once again. So what do we actually end up here with? We'll end up with essentially multiple integrals, 0 to T sub 0, 0 to T sub infinity. This is now a delta T. This is now the function inside here is essentially our frequency transform times T sub 0 cross T sub infinity. Now, we got to put a constant out here. If we don't put a constant out here, this whole thing falls apart. This is going to be another cross with gravitation.
Any rules of transcendental ways so that the camera can carry the formulas for
Okay. Now, what we're getting at here, have to excuse me, I'm recalling this all from memory. I did not expect to do this, so I didn't bring a stack of notes like that to try to reduce to something simple. We again have to put this, which is essentially, now we also have to put in delta t. I'm doing backwards. D sub t, d sub 0, d sub infinity, and d sub frequency. And we have to also put in here a third integral, which is minus f to plus f, which represents the bandwidth. Remember, we're talking here infinite bandwidth. This is holographic. You can take a limited slice of this bandwidth, and you'll still get the delta t function.
The T0 and T infinity along T1 or T2 dimensions?
No. T0, again, is the center of the time torus. We're on a manifold that goes from the edge to the edge of the time torus. As those spinners, as the twisters rotate in the time torus itself is a closed-end spinner. As those twisters twist, they create tangents, which create manifolds in the edge, in the center, where they all cross multiple manifolds. That T sub is 0. Now, the outer edge of the torus is T sub infinity.
Are you referring to those as vectors then, and the vector product?
Yeah, this is all vectors here. We're doing essentially a scalar vector cross product. Because, okay, yes.
On this integral equation here, should there be another integral for the gravity function?
Yeah, right here. G is an overall integral. That essentially is del cross E cross B I'm not sure if I'm putting this down exactly correct. This is a triple del cross product G. Now you got to put here all this crud for J, omega, epsilon, mu, and the gravitational constant, which is usually little g. You got to add that all on at the end of this. This is equal to what, people? 0, real, and plus or minus I, J, K. I is T sub 0. J is T sub infinity. K is your gravitational constant again. Well, this is telling us we have to sum these all things together. We can pick this out. All this drops out. And we get essentially that electric vector crossed to a magnetic vector is through a curl, or the del function, and you curl again to get to the gravitational vector. You got to take this, substitute this up there. This thing keeps growing bigger and bigger. Now, this F sub t, what is this? This is a frequency transform. Now I have to erase the blackboard. Everybody got it before I erase the blackboard. Because I've run out of space.
Tell us again what n equals 0 again.
Here? This is the initial summation of your frequency times 0 times infinity, where you're going from the 0 harmonic to the infinite harmonic. This is everything. This is the whole universe. But of course, we're limiting the bandwidth. So now we're breaking it up into integrals, where we go from a minus f to a plus f, which is giving us the bandwidth factor, because our systems are not infinite bandwidth. At least not yet. Here, let me put this back.
You guys on the first two rows dive a little bit under so that you know the last row of the formula.
Maybe what we should do is bring the blackboard up here. Okay, hang on.
Get rid of this chair. You ready? Yeah. Good. Take it to stand. We'll get the blackboard. My hand is here. Okay.
What is the size of light you
Okay, everybody got this?
You mean have a cross operation with the G?
Mm-hmm. That G vector, electrogravitation, is very important.
Yes. You don't have a cross indicated in there. Yeah. That's lower equation.
Yeah, right here.
No, there's the next one down. The curl equation.
Yeah, you're right.
There you go.
Sorry about that.
What is the O on that top sigma formula, the O after S of that?
This is a mathematical function. Okay, can I go now continue?
Yep.
We now going to go into a little bit of theory on delta pulses. I'll repeat that. I'll repeat it. I only have two hands. Okay, now we got to go into some theory on Dirac delta pulses. What is a delta pulse? You have amplitude in this direction, whether it's voltage, current, whatever, it doesn't matter. You got time this way. You go along, all of a sudden, you get a spike. It goes up, comes down on the same spike. Let's now expand this. That comes out a nice square rectangular pulse. The true Dirac delta pulse, in theory, is pulse width. It's the limit of the delta P is delta pulse. It's the limit of the frequency transform as pulse width goes to 0. Now you're taking this thing and you're shrinking it to 0. What happens, engineers in the audience, when you shrink this pulse width to 0? The bandwidth of the pulse goes to infinity. It starts at the rep rate of the pulse that goes to infinity. Now, consider this. What's the tan? What's the tangent of 0? 0. What's the tangent of 90 degrees? Infinity. So what is this telling us? In the orthorotation world that your tangent represents, because the tangent goes like this, 90-degree rotation is it going from 0 to infinity. So that means, what this means, if we take our limited bandwidth and generate 2 or more 90-degree functions, we can now take that limited bandwidth and make the pulse appear to be a true Dirac delta pulse. This is how the delta T antenna works. Delta T antenna, to review, of course, is a triple delta loop. It ends up being the double pyramid shape. X, Y, and Z. What is this thing? A loop this way. A loop this way. A loop this way. We got 3 delta loops, orthogonal, right angles to each other. Now, if you remember, we had our multiple cross products involving electrogravitation, T sub 0, T sub infinity, and our infinite frequency transform with the frequency coefficients from n equals 0 to n equals infinity. We can't do that. We gotta go from n equals 0, that's your DC component, to some finite boundary, maybe 20 kilohertz. So now we're going to have an integral equation. 0 here, 20 kc here. Take it every hertz, so it means you got 20,000 steps in your integral for your limits of integration. This is 0 to T sub 0. This is 0 to T sub infinity. Now we're going to put in here our delta of n. This will be n. We're going to put in our frequency, our transform of frequency. We're going to put in our T sub 0, which actually is the tangent of 0. We're going to put in our T sub infinity, which is actually here, tangent of infinity. Yeah. So this has to be tangent of 90. I'm no better than any of your other college instructors. We all make mistakes. I'm not alien, no more than anyone else in this room is alien. Now also, I don't know what the correlating equality is, but we have, I'm going to show it this way, G, your G vector. What I'm saying here is we don't understand the proportionality, but we don't need it to bend time. Now, considering that this is tangent of 0, as long as we have some function that is referenced to tangent of 0, or T sub 0, we can satisfy this. Tangent of infinity, T sub infinity. How do we get T sub infinity? This is something I have grappled with for years. Last night, while trying to sleep in this hellhole, I finally remembered how it was done. Anyone know what white noise is? White noise is a frequency transform with all frequencies in it. It's a group of Dirac delta pulses of different rep rates superimposed to make this broadband. So now, to make this broadband function, we call white noise. White noise is 50% correlated to anything and everything. Our reality is 50% correlated to the entire white noise function. Our reality, if you look at it as the whole enchilada, what do we come out with? It's fractals, right? Fractals. Now, if you take fractals over the entire limit, 0 to infinity, what do you come up with, people? A broadband noise-like function. So any Gaussian-type white noise source, which is magnetically focused, since remember the last lecture I gave, we spoke of the magnetic field as being potential field 90 degrees away from us. You have to have a special white noise source which is magnetically focused. Is a T sub infinity reference. So now this is Tesla's whirligig, as I call it. This is white noise. What is Tesla's whirligig? This is what we call our zero-time generator. If you remember, any of us familiar with the history of Nikola Tesla, he worked with all sorts of resonance, or as another friend of mine says, resonance. What he discovered is if you get two inertial rotating masses, inertially rotating, if you can relate the mass of the two objects, where the mass times the rotation of one is an integer relation to the mass times the rotation of the other. They're going to sync together through gravity. So what he built was a motor generator where the speed of the motor times the inertia of all the rotors in the motor generator was inertially matched to the rotation of the Earth. This was developed for the FAA in the 20s because back in the early 20s, FAA was developing landing systems. They had to have a reference that was constant all over the Earth. They didn't have good crystals in those days. LC oscillators drifted like an SOB as we still have today. So he decided to make this weird motor generator locked up onto the rotation of the Earth. Figuring the Earth is rotating the same everywhere, you'll have the same frequency everywhere. I have a number of these devices. Al has one in his possession also. They were built for the FAA in the 60s and the 50s. You turn the thing on, you hear the thing speed up, it whirls its way up, and then you hear it lock in. It doesn't lock into the power line. Why? It's a synchronous motor that they drive it with. 1800 RPM, which is a 4-pole motor on 60 hertz, or 30 hertz rotation. Now, I've taken that reference generator and operated that thing from 58 to 62 hertz. Its output frequency did not change once it locked in. Now, when you went below 58 hertz, 57 something, it dropped out of lock, and then the motor tracked the frequency, and when you went above 62 something to 63, same thing happened. So this generator is locking in to something besides the power line frequency, or else you wouldn't have that window where it doesn't change its frequency, the output frequency. Now, this locks to the rotation of the Earth. The Earth is now inertially locked to the rotation around the Sun. The orbit of the Earth is inertially locked through the inertia of the Sun and the Earth to the rotation of the Sun. The rotation of the Sun is inertially locked to the rotation of our galaxy around the center of our galaxy. The center of our galaxy is inertially locked to the rotation of our reality. Now, people, what is the center of our reality inertially rotated, inertially locked to? Yeah, zero time. So this Tesla whirligig is a zero time reference. We have our white noise, which is a T sub infinity, an infinity time reference. Now, what do we do with gravity here? do we get if we do a cross product of these? Does anyone know? I know, it's difficult.
You get a 90-degree rotation.
Yes. Now, what is cross? A nonlinear function, a mixer. If we had about 16 hours, I could explain the math behind it.
You're just talking about
Two tangent functions, 0 and infinity, 90 degrees. Gravity is the crossing of no activity with all activity. You create a rotating vortex wind between the 2 points. Remember, we just said that 0 time is t sub 0. Time infinity is the tangent of 90, tangent of 0. We got the tangent of 0 here. We got the tangent of 90 here in the white noise. Now we got to take this one off. Well, I'm going to leave the antenna in delta t. Now I'm going to show you how to make this device. Although this is a lot bigger than the device we've made. We'll get into how we make that device later. I'm telling you at this point, I'm showing you the secret of time. Time modulation. Okay, let's put over here our 0 time reference. This has 2 outputs, 30 hertz, fixed, and 30 hertz, phase variable. If you look at the Tesla 0 time reference, it's got a big knob on the front and a dial behind the window that says 0 to 360 degrees. There's 2 30 hertz alternators. One is rotated by this knob and dial. So you can gain precise control by rotating the 2 generators to each other, which relates to the Eldridge owl, because they're now changing the rotation by changing the fields. In this case, they rotate the entire field mechanically. It's got 2 outputs, 30 hertz, reference phase, and variable phase. We take these 2 outputs, we put them into mixers. Now, we take our white noise generator, our general radio. I think it's an 1863, if I recall, which is a little box about that big that has a Gaussian noise tube in it and 2 6AQ5 amplifiers with its levels and a level control meter for its output, has bandwidth limitations. This thing can go to 500 kilohertz bandwidth or 20 kilohertz, or I think it's 5 megahertz also. If I remember, it's an 1863. Get the old GR catalog and look up their Gaussian noise source. This thing, General Radio, this thing is available on the surplus market, a dime a dozen. General Radio must have made trillions of these things. You modulate with the white noise output. Well, also you have another tap. Now, what do we do next? The function you're going to put into the delta time has to be a quadrature function. Another mixer. 2 mixers. This is going to be f sub x, and this is going to be f sub y. This is the dual output from the Montauk chair system. They're a quadrature, 2 outputs are right angles to each other. Then we go here to 2 amplifiers. This one becomes the Y amplifier for the Y loop. This one becomes the X amplifier for the X loop, here and here. So what are we doing here? We are taking our cross-product function that you're using to generate the frequency transform you want to broadcast, putting it in here, driving it to the two sets of coils, X and Y. This is going to create your twister, a rotating, very small donut where the diameter of the donut essentially is 0. If your bandwidth is infinity, so it becomes 1 over the bandwidth. Now, what do we do with Z? It's very simple. Another amplifier to Z. This takes our twister and makes it into a spinner around the antenna. Now, by crossing the two functions, you can now remember, I was talking of taking delta functions of a particular bandwidth. Because you're crossing the two delta functions with 90-degree loops, this will be like multiplying the two tangents together. And this will give us, operation-wise, an infinite bandwidth outside the antenna. You'll get an infinite bandwidth. What are we generating here? A vortex. Because of the fact that this rotating vortex is built up of a frequency transform function, which by the activity of the right angles of the antenna, 3 right angles now, it's all going to appear to be noise, because we're modulating our signal with a noise gated by the 30 hertz.
What about the FX?
They are coming from a computer, a mind amplifier. This is your function that you're broadcasting into the time domain. I'm telling you, specify it's got to be 2 functions in quadrature to each other. It's got to be biphase quadrature, which, to our medical people in the audience, what organ in our body works on biphase quadrature? The brain. Somebody, who was the bright man that said the brain? Stand up, sir. A round of applause. We got somebody that's awake in the audience. I've just shown you. Now, you can fine-tune the phase relationship from the zero-time reference. What you'll find as you tune through, you'll be able to actually fine-tune how far in time relationship this will vary. If you match the 90 degrees here to the 90 degrees here, if the fidelity of all the information channels is infinite, what do we have? We have a controlled time portal in the center of this antenna. Now, we've left one piece out. How do we construct our delta loop? Let's take one loop. Do you have any old radio men in the audience? What's the next thing we do with this, sir?
Well, that looks like a rhombic antenna to start with.
You shield it, right? We're making a magnetic probe here. So you put a shield around this thing. What do we now got? A radio direction finding delta loop. But what's going on here? We're taking E cross B and stripping the E off it. What do we have, folks? We have a function which is already ortho-rotated 90 degrees out of our reality. Now, how do we control this? We put right down the center of this thing an antenna, a rod. At the same time, we have our ground function. We connect the rod and the ground to a switch, a commutating switch. I gotta make this dotted. We drive the switch from the rotation of the zero-time generator. It's got to be integer related to the rotation of the wheels in the zero-time generator. What do we hook here? We hook our radio transmitter. Now, this is a very unique radio transmitter. It's ISB. Any of the hams know what that means? Independent sideband. This is a double sideband suppressed carrier transmitter. But lower sideband is at 0 degrees. Let's put it over here. Is at 0 degrees. Carrier equals 90 degrees. Upper sideband, upper is 180. This is called a bi-quad, bi-phase radio transmitter. We put into the upper sideband F of Y. We put into the lower sideband F of X. Now, at the same time, we take this transmitter and somewhere in the amplifier chain, we put a gate or a mixer, and we put our white noise. We take the output of the transmitter, put it into this RF switch. How many people have seen the electrogravitational generator, which is a torus coil with another coil inside of it where they put a high voltage potential between it? This is what we have here. We put this between ground and our RF signal back and forth. From the Eldridge, the 4 coils created the delta T magnetics. The RF transmitter created the electric field component of this. Now, when you do del cross B, del cross E, del cross G, sum it all to 0, it equals 0, all imaginary. That becomes your time modulation. Now, your lecturer is going to have to take about a 2-minute break. I got to go to the facility. I actually have to. When we come back, we're going to talk about the transistor and the special device that Al was talking of. Anyone know what a tunnel diode is? All right, we got one bright individual. How do you make a surface barrier tunnel diode? You take a piece of semiconductor material, silicon, germanium, gallium arsenide, it doesn't matter. Let's say it's P. No, let's say it's N. N is easy to make in the old days. You deposit, you take this and you etch it so it's absolutely flat, electrochemical etch, which means you take a jet and you put out a chemical, and then you take that conductive jet and you put a voltage source between it. And you etch, electrochemically etch, you use a chemical which is a salt of the semiconductor, and you electrically chemically etch an absolutely flat face that is molecularly flat on the surface of the germanium crystal. Then you shut that off. Then you put on top of that a metallic contact. Now, because of the electron pressure coming up here, hitting the barrier coming back, it builds a depletion region without putting any polarization across it. It builds a depletion region. Now, it's this thing with nothing has a depletion region. Now, if you put a current through this, what's it going to do? It's going to build up electrons on one side or the other side of the barrier. When you reach a particular point, they're going to punch through the barrier. But it's not a punch through, they tunnel. Remember, we built up a potential spatial charge, and as long as you don't exceed the charge across the barrier that the spatial charge represents, your current now is tunneling. It's not going through, punching through like a transistor does, where you combine the holes and the electrons. I don't expect this to be clear to everybody. This is essentially for technicians and engineers at this point. The people who understand, you're following at this point. Now, what's the characteristics of the tunnel diode? I versus voltage. It goes up, then it comes down, and it goes up again. This is your tunneling region here. What this is saying, as you increase the voltage, the current goes down, not up. That's your negative resistance. Any negative resistance device you can use as an amplifier. Now, let's go into what's actually happening in this depletion region. I'm going to take this point here and expand it. This is your indium contact. Here over is your germanium. This is the depletion zone. This is the germanium. This is the indium. Now, as you bring a potential this way, remember, Al was speaking of a rotating vector on the edge of a time. This is going to create a rotating vector on the edge of electron flow. You follow so far? This is the spinner and twister creating around the tunneling electron. What is this twister, spinner? It's a vortex. It's a vortex, folks. What is a vortex? A hole in our space-time continuum. Now, what happens if we put a Dirac delta pulse in this current flow? The vortex will instantly turn on, the vortex will instantly turn off. What has all the mathematics that we've gone through say when we take a vortex generation, turn it on, turn it off? You do a frequency to time transform. So the faster, the narrower you pulse this thing on and off, this now becomes a miniature time vortex, which means when it goes from this end to this end, it becomes electric current here. It's electric current plus a time current. So we got E here. Here we got E plus delta T. What we just learned? A tunnel diode is a delta T diode. Does the engineers and technicians follow so far? Now, let's go another step further. As I erase, I'm going to talk. In 1952, the aliens contacted President Eisenhower and said, hey, we want to get together and talk with you. We all heard about our treaty with the aliens. One of the things they asked us to do is, we got this problem, we got a reliability problem of a very strange semiconductor device similar to your transistor that we use on our craft. We want to have you and Earth be this sector of our galaxy source for these devices. We'll show you how to build them. What did they show us how to build? No? Surface barrier transistors. The tunnel diode came out of the surface barrier transistor research. According to a friend of mine, let's call him Clark in the book, he worked for a company called the Electronic Transistor Company. In 1946, 1947, Osborne, Shockley, that crowd working for Western Electric had formed at that point in the 50s. Western Electric split up. The semiconductor manufacturing part of it split off, and it was essentially owned and run by Osborne, Shockley, et cetera, et cetera, et cetera. What did they call this company? The real name is the E.T. Company. They knew all along that the transistor developed by Bell Labs in the mid-40s was from the initial contact with the K group in the 30s. That was the first technology exchange. They gave us the crystal amplifier that we call the transistor. Now, they were hoping that at some point in the 50s, the ET involvement would be announced to the public, and they could capitalize on that their company is developing technology given us to us by the ETs. E.T. Company. Now, they were not at the point when they formed this. They weren't going to call it the Extraterrestrial Company. They had to come up with a name for the crystal amplifier. E, of course, is electronic. Company, of course, is company. They went through name after name after name for this device. They came up with one name, transistor, that had a T. So it became the electronic transistor company. This was the R&D production facility, used to be Western Electric. In other words, Philco, Sprague, RCA, General Electric, in those days did not have their own facilities. They bought all their devices from the Electronic Transistor Company. Of course, in the mid-60s, the Electronic Transistor Company became a public corporation. They put out a catalog about that thick. You could buy any old transistor you wanted from, even the discontinued ones. Now, the Philco Research Laboratory in Philadelphia, Pennsylvania, was run by Philco, the Electronic Transistor Company, and U.S. Navy. Clark tells a story that there was a man by the name, he called him Onopole, the man's real name is Annapolis, who was an officer in the E.T. Company. Clark used to work for Annapolis when he was going to RCA Institutes. He tells this story that Mr. Annapolis, or he put it on a pole, would come in and told him, you know where these crazy little transistors you were working from came from? Clark says, oh no, I don't know. He said, well, he was assigned at that point to the Navy Philco Research Laboratory in Philadelphia. Now remember, we're talking 60s. This goes back to 1953. And that they took a back end of the plant that had the research facility, cordoned it off entirely, put all sorts of high security in there. They developed a surface barrier transistor in there, and this fellow told Clark that every day these tall characters would come in black trench coats, black hats, and like a mask over their faces. When they got in the back, they took the trench coat off, the mask, and the hat, and they were literally 7-foot-tall gray aliens. Clark said that Annapolis described the gray alien perfectly, and that the gray aliens were telling us how to build these transistors and helping us develop the manufacturing process. And this was surface barrier transistors. I think in a little bit Al can talk about what he psychically picked up they were doing with these transistors, but either way, let's now go in and consider, what is this transistor? We take our P-type material. P-type material is what, Mr. Engineer? A whole electron source. This is germanium semiconductor that is doped with an ion which has excess electrons, so it's a source of electrons. I'm not going to go any deeper into semiconductor theory. Now, instead of having one electrochemical etch jet, you put two. And you have two batteries here. I don't know if the polarity of the batteries are correct. I don't care. And we smooth out two sides of the crystal. Yeah. It goes like this. I see somebody remembers the surface battery electrochemical etching process. Stand up, sir. Let's have an applause for him. Now, once they do this, what do they end up with? Let's look at this little tiny piece here. I am the consultant today, the engineering and production consultant for the ET company, by the way. This is where I got all this information from. Now, you take one, you deposit the indium material on the etched surface. Now, you may put some other crud on here and call it MADT, call it MAT, call it SBAT. You know, the surface barrier transistor was owned by the government, and the ET company tried to capitalize on it, change the design a little, and what they would do is they would change the emitter junction. Now, what you have to consider is this. The spec sheets say that it resembles a PNP transistor. What's going to happen here? When you change the bias on the zone that is outside of the, what the hell they call, electron pressure generated depletion zone, you're going to move this. You're going to create vortexes. Tunnels. We now have taken our tunnel diode and made a tunnel transistor. Now, what's going to happen here if we make a common emitter amplifier, ground this, I'm going to make it dotted because we're talking of AC ground. We put our pulse here, and we put our load here. We're going to control the tunneling between the emitter and the base, and the base and the collector. What's going to happen is the delta T current, based upon this pulse, is going to circulate this way. Which means now we're going to take our input signal and convert it to an electrical signal plus a delta T. This is your delta T amplifier. What do we do with this thing? Take this thing, connect it to, as Al was saying, a 555. Put a current limiting resistor so we don't blow the hell out of the base. You can't get them. No. I lucked out because after the boss man gave me a pile of them, and then maneuvered me to give the pile back because he was told by the government, no, you can't do that. I remember seeing in the Allied Radio catalog MADT transistors. So I got an old catalog, looked at it, opened up the page, sure enough, there it was. So who is Allied Radio today? Radio Shack. So what I did, I called Tandy in Fort Worth and said, hey, I'm interested in a product that you guys used to sell in the late 60s. I gave him the part number. They went into the computer. Oh, yeah, we got those, sir. We got 40,000 of them. So I say, well, how come we don't have them in the catalog? Nobody wants them anymore. We still got them in the warehouse. We don't throw anything away. So I say, well, send me some samples. So they send me about a dozen samples. Yeah, these things are surface barrier transistors. So I call them up and I make a deal and I buy all 40,000 of them. And I said to them, anyone else in the country you know of have any others? So I've called a few other small dealers, you know, associated dealers, allied dealers, and I got about another 1,000 on top of that. At this point, just as I did with radiosondes when I built the Biosonde, I cornered the market on surface barrier transistors. If you go to ET company today and order them, although they got them, they're going to tell you they don't got them because there's legalities involved since the company was told in the 70s to destroy them all. They're not going to admit to anyone outside of the group, which I'm part of, that they had these transistors. So, where do you get surface barrier transistors? From Preston, right. This is how the Delta T transistor works, and I'll give it back to Al now. Because what I did is 6 or 9 months ago, I handed out one of these little blue boxes I prototyped. Oh yeah, I forgot to describe the coil. What we're using is a coil with 4 pi windings, spider wound. Difference is, the bottom one is spaced further away. Just as Tesla noted, you could direct the direction of the flux by changing the spacing. So we got a coil with 3 closely spaced windings and a distant space winding, and the time flux goes this way through the coil. Well, somebody had to ask that. It's really complex. I know Al may want to refer to this, right? So I'm not going to erase this. You take your coil form. You rotate it. You take your feed, and it goes up and down each time it rotates. What you get is you build up a winding a little at a time, and you do 4 of these. Each one is called a pi winding. It's called pi because it goes from 0 to 360 degrees each time the form rotates once. And you just keep taking about number 60 wire, and you build it up. The whole impedance of this thing is about 1,000 ohms. The current through the transistor is maybe about 10 milliamps. The whole thing draws about 15 milliamps from a 9-volt transistor radio battery. And from that point, I'm going to give it back to our distinguished Eldridge survivor, Mr. Edward Cameron. Come on, Mr. Edward Cameron. As I said, I gave him one of...
I'll dig in my little goodie box here. And that's just where I put it. Here it is. And I'll come out with a Delta T generator. It's not a very big device. You can actually stick it in the coat pocket. The entire circuit, the coil, the battery, everything is in here. If you want to take a picture, you're welcome. And it has a little LED in the back to let you know that it's on. A huge filter capacitor to smooth out the current. I didn't show every detail of the circuit. It's not really necessary. But now you got a very interesting function on this. If I remember correctly, Preston, the surface with the 4 screws is the output side, right?
Yes.
Right. And if you turn it to where the little legs for this box are, it's a standard ordinary Radio Shack or whatever plastic box. That's the vacuum cleaner side. And I also have here a little adjustment pot there in order to change the frequency. Right. Right. And the coil sits in here. Literally. All right, I have a little screwdriver in the case I think I can use. But in any case, I don't know how many of you people are sensitives, but we're going to find out. Turn this thing on. It's now on with a little red light. See how many people feel anything. Anything at all. It's on. You know, those who are scientists and engineers usually are not too sensitive to subtle effects, we'll put it that way. Little red light says it's on. And some people have noticed if I turn it edgewise, I get a terrible headache. Not trying to suggest anything, but I want to see whether anybody feels anything in here. Okay, now if you turn it this way, it acts like a vacuum cleaner, a very strange vacuum cleaner. It doesn't suck dirt, doesn't suck air. It will react in a metaphysical manner. I have played with this thing now for some 6 months, more than 6 months, perhaps 8. And I found the frequency setting is fairly critical for some people. But if you have a problem with how shall I put it, an energy implant, not the solid crystal type which the aliens and or the government use, but an energy type implant, this device will pull it off the body. If you have problems with, well, you could almost say ET attacks. If you have problems with entities of any type which are attacking you, this thing will usually end the problem. They don't like it. I've used it more than once for that purpose, including up in North Carolina recently, where we had an infestation of ETs at a certain symposium, which Preston and I and Duncan were at. They didn't like this thing at all. They left. They were not physically present in the sense of being you or I or anyone else in the physical, normal reality. They were present in an altered or a parallel reality. Now, this gets into a very interesting aspect, which I don't have time to cover fully, but very briefly. There is alternate realities. There are several of them. The government does have means to cross over into these other realities. There's a project called Project Winter Haven, which was developed parallel to the Montauk Project, probably under the cover of the Phoenix Project. And this is a project for interdimensional travel. And by using interdimensional travel techniques, some of these so-called spirits turn out to be quite real, because what is the spirit world but another reality? Quite physical to their own references. Your dream world is quite physical when you're in it. Therefore, one has to come up with a question: what is reality? We think we know what it is because we can hit a table. If you hit a car under a brick wall, you smash the car, you might smash yourself. If you could do an alternate reality shift quickly enough, you wouldn't hit the wall. Who knows what you'd hit in the other one. But this gets into a very strange and difficult area to analyze. What is reality? We accept ours as real because we've been educated to it. We feel it. We know it every day. But there are other realities and other people there that know their reality as real. They probably look at us as ghosts, if you will. But there is occasionally crossover under certain conditions, dimensional changes, dimensional doorways, which can be artificially created, or naturally they exist without artificial creation. But a device like this can prove useful in terms of if you got uninvited visitors that you don't like. Okay. We don't have it in production yet, and I can't really give a price. This is one experimental unit. Preston had built one or two others on a breadboard, which are about 5 times this, cover a 12 by 12 inch breadboard. But if we do get it in production, it's I can put it this way: it'll be more than $100 and it'll be less than $1,000. The circuit is fairly simple, but we have to consider a number of aspects: frequency stability, adjustability, durability. We still don't really know how durable that transistor is. It's not a low voltage device, as most germaniums were in the past. Typically, a germanium had a VCE rating of about 10 volts, 9 volts to 12 volts, 15 was high. This is a 9 volt transistor. These are hand-picked to handle about 25 volts. And that's one of the unknowns at this point, is how stable is that transistor against transients. You won't get much transients with a big filter cap on a battery. But it might if you're in an area where, let's say, there was a powerful radar transmitter or some other very powerful electromagnetic transmitting device, anything from an FM transmitter to a TV transmitter. They'll put up a lot of voltage if you're too close. And if the circuit board happens to be critical in terms of the layout, the length of the leads, and you hit a quarter wavelength lead, you can build up a rather high voltage internally on a transistor because of the lead lengths on the board. Right, that's the other aspect. The coil is directly connected. Right. Okay, I'll see if I can find a screwdriver and take the lid off so you can see what it looks like. Because it's
What have you practically done with it?
practically, I've used it to end problems with people who had attacks of one kind or another. Energy attachments, one could call it, which is a form of implant, but it's not a physical crystal type. Physical crystal types have to be removed surgically. Biological implants can be destroyed by electronic means. This is not powerful enough to do it. It can be used to stop a form of mind control where people are trying to impinge those who have the capability of transmitting a form of mind control. And I'm talking about hardware. I'm talking about mind control from another person's mind who has the capability, impinge on a secondary party, bad energy, feeling bad, et cetera, et cetera, et cetera. One can do a number on those people which breaks it and gives a person back some peace. Then you have to look at the other aspect of who is this and why are they doing it. Yes?
Have you done any experiments with, like, time anomalies? Does it change the rate of time?
It changes the rate of time in a very localized area because the output is a cone of energy. And since time is one of those elements which is basic to the universe, it does not know a distance limitation, even with a small box like this. There is no 1 over d squared or 1 over d attenuation. There is no attenuation. Sorry? What does he... It is localized because of the size of the coil at this point on the edge of the box. It fans out as a cone. It fans out as a cone of energy. The further you go, the more it spreads. But it does not attenuate insofar as any tests I have made on it are concerned. Half the people that pick it up are sensitive to it 2,500 miles away from Phoenix to the East Coast. I'm sorry? Nope, haven't had any so far. There's not enough power. You would have to have a very large delta T function for that, and a considerable amount of power, more than a 9-volt transistor battery. Perhaps something which is charged by a 12-volt car battery might do it. Yes? It is basically a psychotronic type device, psychotronic effects, yes. And in that sense, the effect is not physical insofar as any affected tissue is concerned, so far as we can determine at this point. We have not yet built a detector which can directly measure the output of this thing. We're working on that. And that's another aspect. If we say we've got something coming out of here, we've got to be able to prove it. We can prove it indirectly by the subtle effects that some people pick up, but that is not hard proof. That's very soft proof. Oh. Right. If you have this thing properly modulated, it will affect the person that way. If you put a scramble signal on there, there's no telling what it can do to a person's mind if there was enough power. So the government knows how to manipulate these things. They use mind control devices all the time. Okay. Mm-hmm. Okay. Well, I had it on the vacuum cleaner side, which says it was pulling and then it stops pulling, and that's probably what you felt, the end of the pull. Now, not everybody can feel this device. I'm not... Anyone else that had a feeling for it? You did. Anyone else? Okay. It says that there was a low percentage here, but at least there were 3 or 4 who did feel it. 5. You have a question? Okay.
What are the possibilities of voice modulating the signal coming out using it as
Transmitting device, receiving communications. Very definite possibility, but one has to have a detector in order to demodulate, in order to use it as a useful transmission of intelligence device. You want to have 2 links, a transmitter and receiver. This is a transmitter only, and we do not have any modulating techniques on this. It is strictly a square wave generator driving it. Yes?
This is maybe a question more for the rest of it, but why couldn't one use a field effect transistor, which has very narrow base region?
Well, field effect transistors are not tunnel.
Yeah, that's a very special function.
The tunneling is what makes this work.
Yeah.
This is a tunnel transistor.
Just a comment. My experience with those type of devices or those type of diodes and transistors is that they're very sensitive, and if you place them in a properly machined cavity, you can get bandwidths up to 300 gigahertz.
Yeah, I know.
And
Yeah.
right time.
Gun diodes, right. They seem to have disappeared from the market. There are many things you can do with the properly built germanium devices you cannot do with silicon. And this is a technology which has been almost forgotten and buried, but probably not in certain government circles. Anyway, you have another question? Okay.
Earlier in the presentation, you said you were going to mention what happened to the vessel and the soul frequency.
Yes, it's interesting. You did bring that up. Some interesting feedback on that recently. The feedback has come back to us recently about the fact that it is still in the Greek Navy, and that over a period of years the Greeks have had a few strange things happen. They found a number of locked rooms which they could not get into until they forced locks. And they had some closets or standard type ship's lockers. They finally forced one open and a skeleton fell out. And they found wiring all over the ship that goes nowheres. It's just sitting there unconnected, and tons of wiring apparently with no connections to anything, and they don't know what it is. Well, I think I do. All right, I think we all do by now. But that's some of the feedback on that. I've heard other wild stories about when they first had the ship, they were getting some very anomalous effects which caused them to strip the ship and repaint it completely before they felt the stuff, whatever it was, die down and they could go out to sea with it. The stories are anecdotal, and I don't have any first-hand evidence or proof of it. Yeah, they want it for a museum piece. Ho, ho, ho. There'd probably be a cutting torch applied to bury it forever. That is also in the communications we have. The government would like to get it back. One other question? Okay. In the back.
It would appear to me that in 2023, that the algorithm might disappear, regardless of whether you have machinery or not.
Well, there is no machinery on the Eldridge now other than a normal complement for a warship. Why do you pick 2023? Oh, 3. Okay. It's an interesting thought. It didn't go into 83.
But, you know, when you went back and cut the wire, cut the cable, you were at the particular angle between 0 and 90 to do that. So what is to say that the spin hasn't rotated slightly back into the plane before you get
Yeah, that's an interesting thought in terms of alternate realities and repetitive cycles and all of that. We've explored that thought-wise, and we do have reason to believe that we probably have been through this circuit more than once, but that's something we don't go into now because we're not sure of it. That's an interesting thought. Thanks. Yes? No. No, almost all of that type of device has been withdrawn from the market. Nice little neat widgets. And the gun diode disappeared for about the same reason. Today you have a restricted market in terms of what electronic devices are available to the general lay public or the general experimenter. I haven't seen or heard of any, and I know somebody who's been trying to locate them. Maybe they're surplus. Whatever. Okay. Well, I think that's about the end of our talk here.